Mess up the people at home. All right. So like I was saying, we're going to finish up the background on water. This is where we ended last class. So what we have is, you can see where Earth is on this. That's the surface of the Earth. That's where you are right now. That's the pressure you're under. And if we change the temperature, we just move sort of left to right and right to left at that particular pressure point. And you can see Mars has much lower pressure, right? Way down near the bottom of that XY graph. And as you increase the temperature at Mars surface pressure, you can see that it goes directly from a solid to a gas, right? We talked about that last class. That process is called sublimation. Dry ice, CO2, works that way on Earth's surface. So if you want to know how water would work on Mars' surface, it's just like CO2 would work here. It doesn't go through that liquid stage. Dry ice, if you've seen it, it's cold, it's a brick, and if you put it out, it just sort of turns into a gas, doesn't it? It just sort of goes away over time. That's exactly what water would do on the surface of Mars today. So if we go to Mars today, should we see lakes and rivers and streams? No, the pressure is too low. And I asked you at the end of last class, if we wanted to find life that required liquid water on Mars, where would we have to go? Yeah, you have to find higher pressure, right? You have to move up on this graph. And to do that, you could just go down in the subsurface, down in the dirt and the rocks. So down there may be a zone where there is liquid water, okay? So this is a topographic map of Mars. You know what's cool about Mars is we actually know the topography of Mars better than we know the topography of Earth. Honest to God truth. We've had a satellite there for over 20 years, and all it does is it sort of circles the planet. It sends a laser down to the surface, which bounces off the surface and goes back up. And the amount of time it takes that laser beam to go down and up is a function of the topography. It's going to hit the high areas first and come back quicker. So we have great topography of Mars. Fantastic. We don't have that great a topography of Earth because we have 70% of the Earth's surface covered with water, and we don't have great sonar of all parts of the ocean bed. So it's weird. We actually know this other planet's topography much better. So what I want you to do, and this will play back into water here in a couple minutes, is I want you to take about 2 or 3 minutes and write down as many observations as you can about what you notice about the topography of Mars. Blue areas are low. Doesn't mean water, just low elevation. Red and white areas are high, okay? So just jot down. You don't have to understand what your observations mean. You just have to notice things about the surface of Mars. So just take a few minutes and see what you come up with. Okay, what are some things that you notice? Anything at all?
Craters.
You see lots of craters, right? Are the craters evenly distributed on the planet? Most of you are shaking your head no. What do you see? What's that? You see lots of them in the high elevations, right? Look up here. Do you see lots of craters up in the northern part of Mars? Not many craters up there, right? Lots of craters down here in the south. And you said the high areas. Are the high areas equally distributed on the planet? No, you notice the south is generally high and the north is generally low, right? Mars is pretty weird. It has, you see this dot right here, this highest area right there? That's 90,000 feet high. We don't have anything on Earth that even rivals that. Mount Everest is 29,000 feet high. See this low area here in this bullseye? That's about 100,000 feet lower than the average. So we have a range of elevations on this little planet. Mars is about the third size of the Earth. That is so much greater than on Earth. They have way more wild topography on Mars. Okay, so we have lots of craters in the south where it's high. Okay, what else do you see? You probably noticed this big blue eyeball down here in the lower right part, right? That's called the Hellas Basin. It's probably a giant meteor that hit the planet at one point in time. And there's a couple more that you can see. There's one here in kind of the southern left part of your diagram. So some big craters that have hit it, in addition to all the smaller craters. What else do you notice?
Valleys.
You see some valleys, right? Where do you notice a big valley?
Right there. Like,
Right there?
Yeah.
Yeah, that is a huge valley. That's called Valles Marineris. It's the biggest valley in the entire solar system. From that side to that side would be the same distance as across the United States. The Grand Canyon would be just a tiny little sliver of land within it.
How far is it across?
Across this way can be more than 100 miles, a couple hundred miles. It's a gigantic canyon. Nothing on Earth rivals it.
So how is that formed without surface water?
Isn't that a great question? How do you get a big old canyon?
Maybe a glacier?
Okay, so it looks like it's been eroded, right? It looks like it's been dug out. Sometimes you get big craters from tectonics, the planets sort of pulling themselves apart. And some people have speculated, well, maybe there's a big rift system here, you know, where that Mars is being pulled apart and making a big canyon. But look at that canyon closely. Where does it start? It starts in this high area, right? What else do you notice about that high area? See these big old dots up there? Those are volcanoes. That particular volcano right there is Olympus Mons, biggest volcano in the solar system. Mars is really cool. It's this little planet, but it's got the biggest everything. You know, it's a wild place. And then these are really large volcanoes as well. Olympus Mons is bigger than the state of Colorado. It would completely cover the entire state. It's 90,000 feet high. And this canyon sort of starts up where all these volcanoes are, right? And then where does it go? Looks like it goes, and see, it goes this way, and it sort of empties up here to the north, right? And you said it looks like water to you. Do you see other canyons up there that kind of look like water made? There's quite a few, right? I mean, that looks like a delta almost.
Yeah.
There's some water up there. I'm going to show you some pictures in a minute that show the surface of Mars, and these canyons look exactly like water's carved them, right? But what did we just say 5 minutes ago about water on Mars?
It's not liquid.
No water on the surface, okay? Come back to this, but look at the north here. No craters, right? Very few craters. And then down here it's heavily cratered. Now, when a planet sits out in space, it gets bombarded by meteors all the time. Here on Earth, we have this atmosphere, and our atmosphere tends to burn up most incoming meteors, so we don't get hit with as many. Mars doesn't have hardly anything for an atmosphere, so these meteors just come in all the time. And over time, it should just kind of blanket the planet with craters. But there's not many craters up here, right? Can you explain why not? They should be there, right? The whole planet should have been hit with this. Yeah?
Is there less gravitational pull in the North?
Nope. Gravity is the same everywhere. I will tell you that just about everybody that studies this stuff believe that this area got hit with just as many meteors as this down here.
It's just
Covered up.
by the storms and stuff.
What could cover up such a big area? Dirt, right? And what if, okay, we have to suspend what we know for a second. What if there was an ocean up here? It's a low area, right? What if there really was liquid water on Mars at one point? So you got this ocean, right? What happens in our oceans? All the rivers sort of drain into it, right? Carry all that sediment. Not only would you have an ocean preventing the meteors from hitting it, those oceans would then be filled with sediment that would cover up. But I just told you there can't be water on the surface, right? Maybe. Maybe not. All right, I'm going to zoom in on this area right here, okay? Right where you guys have sort of been talking. Let's see. This area right here, all right? Where you have the volcanoes and you have that big rift system. All right, there's a blow up of that area. So you can see there's Olympus Mons right there. That's that giant volcano, bigger in Colorado. 3 other huge volcanoes there. And then you have Valles Marineris right here. And look at this area right there. What does that look like to you?
Almost like a delta.
Looks like river valleys, right? So the idea is that there was some liquid, maybe it was water. Some people have suspected maybe lava flowing, because there's so many volcanoes up there, right? That maybe lava was moving so fast that it could dig out that area. In order for there to be liquid water on the surface of Mars, what would you need? Going back to our diagrams from last class. You need more pressure, right? You're under pressure, right? You're under more pressure than you would be on the surface of Mars. What's the origin of that pressure? How come you're under pressure? What's happening on Earth that's putting you under pressure right now? You have an atmosphere, right? And it's being pushed down by gravity. You don't feel it because you're used to it, but that's what's happening. On Mars, today, there's essentially no atmosphere. What if there was an atmosphere way back in the past? There'd be more pressure, right? So the idea is that maybe early in Mars history, there was more pressure because, notice all these volcanoes? Those volcanoes are going to give off lots of gas and create an atmosphere. And there's clearly a lot of volcanic activity at some point. These volcanoes, we guess, are 2 billion or more years old. They're really old. But maybe back when they were erupting so much gas that there was an atmosphere on Mars. And then the gravity could pull that atmosphere down on the surface and there'd be more pressure. And maybe enough for water to be stable. So it could be that maybe Mars did have liquid water, rivers, oceans, way back in its early history when these volcanoes were creating an atmosphere. But they stopped erupting 2 billion years ago, and we know that slowly atmospheres will just sort of bleed off into space if you don't replenish them. Here on Earth, we have volcanoes that replenish the atmosphere all the time. We have biology that takes CO2 and gives off oxygen and creates an atmosphere. But maybe on Mars, that all happened really, really early in its history because it's a smaller planet. And if there was water on Mars way back then maybe there was life on Mars way back when. So Mars is clearly a much different planet. The other idea is that Mars never had much of an atmosphere. Now, I asked you a minute ago, today, where is liquid water most likely to be found on Mars? We know it can't be on the surface, right? Could be down underneath. We know there's lots of ice beneath the surface of Mars. We actually have a little satellite there, and it sends neutrons down to the surface. And one thing that we've learned about neutrons is that they bounce off ice. So it's a neutron detector, and it hits the planet, and if there's ice present, those neutrons get sent back into space, and this little detector detects them. So they've detected ice all over Mars, just beneath the surface. And there's more pressure down there, right? So what if the ice melts? What if by these volcanoes you get lots of heat, right? That heat can warm up the ice. It's beneath the surface, right? There's enough pressure, it forms water. If that water rushes to the surface, is it stable today? No, it either wants to freeze or turn to gas, and it will. But it can't do it instantly. It takes time, right? So while that water rushes up, it runs down this canyon and empties up here. And the idea is maybe Mars has had a whole bunch of, they call them transient oceans, where you get these massive outpourings of melted ice, fills up the north, and then that water either freezes or turns to gas and goes away. So either way, Mars is a weird planet, and it just kind of goes to show that you can look closely at this and look at the topography, know something about the stability of water, and get some ideas about what's happened to a planet that we've never been able to go to ourselves. So this is an image down here, a much finer scale image of some of these areas. You notice they just sort of originate out of nothing, right? And you get these really nice water-looking canyons. And it could be that liquid water is just pouring out of the ground there. Here on Earth, we're used to water being dropped down on the surface by clouds and rain, right? On Mars, it might be coming from down below, a really different planet. But there might be life under the surface, all sorts of crazy things. So we'll talk a little more about other planets here as we go forward. So there is evidence that water flowed on the surface, but we know it can't exist on the surface today. So the two main ideas are that Mars may, in its early history, have had a more extensive atmosphere from all those volcanoes putting gas up, more pressure, maybe water being stable. A good friend of mine studies this stuff. He's at the Smithsonian down in Washington, D.C. And this is the idea he likes. He thinks that Mars was a warm, wet planet early in its history. He thinks he sees evidence for rainfall in the rocks and all sorts of crazy things, very different than what it looks like today. But there's probably just as many people that think he's nuts, and they think, nah, Mars has always been kind of this cold, dry planet without much of an atmosphere. And all of these water-like channels you see are from water that's formed underground and then rushes to the surface. Once it's at the surface, it doesn't want to remain liquid. So it either turns into a gas or it freezes, but that takes time, especially if it's a lot of water. Which to me would be kind of cool, because if you think about it, if the water rushes up and it turns to gas, it's going to be boiling. So it's going to be a boiling river, but it's not going to be hot. It's boiling not because it's been heated so much, it's because the pressure's so low. So you'd see this water rushing down this giant canyon, and it'd be boiling constantly. kind of weird, wild stuff, but all right, do you guys have any questions on this?